This is Scott from KIG. It's October 2019, and today we're going to do a little overview video and runoff of this 5-ton K-Chill K-Series chiller that's in our shop. In this case here, it's shipping out to a customer in Texas. Now again, this is a 5-ton chiller. This one is 230-volt, 3-phase power. The top section of the unit is the fan and condenser and compressor. The lower section is some of the refrigeration pipe, tank, and pump. Now in this case here, this is going outdoors in a warmer environment, and it's running, we're going to run fairly warm process temperatures. So this unit, as opposed to one that we make this size for a colder glycol application, this unit does not have insulation on the tank or the pump or the internal glycol lines. However, the same fundamental unit we would use for a brewery 25 Fahrenheit glycol application, in which case you would see all these internal lines insulated, the pump head insulated, and the tank well insulated also. Not to mention, without going into further detail, we would reroute the direction of the piping flow internal here, such that the return flow coming back to the chiller would not require any pressure. That's a normal thing that we do if we're repiping something for a jacketed tanks application. In this case here, that's not what it's going to. It's going to a more industrial application. So we're leaving it piped in its conventional manner. So we have a 1 horsepower stainless centrifugal pump there. We do have a automatic low flow bypass pre-calibrated and preset at the factory. So if the flow stops or is restricted going out to your process, in this case our process is just a test loop, we would that valve would open up, it's spring loaded, and we would get enough flow and GPM back to the heat exchanger here. This unit does have a flow switch for safety. If that flow switch, which again is also set at the factory for approximately 2.4 GPM per ton, if that flow switch is tripped, meaning not enough flow, it will shut down the 20 volt power to the unit, and the refrigeration will not run. The controller will power down. However, the pump will still run until you diagnose what the problem is. We do have our refrigerant sight glass there. There also our thermal expansion valve and our braze plate heat exchanger. Also on a lower temperature application, for whether if it's in a warmer climate, a colder climate, or if we're running lower temperature glycol, that would be insulated also. But again, I'm going to run it down to 25 Fahrenheit today just for the test, so we'll get some it will get some frost on it. But again, this is going to go to an application. This exact unit's going to go to an application out in the field where they're running substantially warmer than that. So our controls are up here. Then that obviously will arrive with a metal shroud over that. The controller, this nice little Dwyer controller, will ship loose. It's on a 30-foot cable, so it's this is an outdoor chiller, but you can mount this controller remote, and it's just simply color-coded. You just match up the wires on the right side here, which you would thread through adjacent to your controller power or your chiller power, and just match it up with the same color internal wires here. This is our pump contactor on the chiller. This is our main power contactor. This is our controller transformer, and this is preset also at approximately 100 seconds, give or take. This is the low pressure refrigerant bypass that helps us on cold morning starts, so that the unit doesn't trip out on low pressure. On this unit here, the low pressure, high pressure, and fan switching, pressure switches, and it does have fan switching for the low ambient control. They're all internal down below in here in the condenser, and they're also all auto reset which is kind of a nice, simpler way of doing it. So this unit we have been testing for a while. We're going to simply turn the toggle switch on. We just have it hanging on the side of the condenser here. Pump turns on immediately, and the Dwyer controller does a little self-test here. So to change the set point, which we have set kind of high right now, you just simply press, you don't hold, you press set once, SP comes up, press it again, then tells you what it's set at, and then we're going to bring it down to 25. And press set again, and press set again. That just goes back to 25, but it's going to default back to what the process temperature is, and there'll be a little bit of a delay before the compressor kicks back on here, or before it turns on and starts cooling. This unit here, this specific unit, because it's going to run basic water out in the field with a very little glycol mixture, if any, is going to be leave the factory with a 44 Fahrenheit lowest set point. But for glycol chillers running lower temp, it will be set at 25 Fahrenheit. In such a case like that, we want you to run a 40 to 45% glycol concentration in the reservoir. That's a 30-gallon reservoir there. For a glycol application, it will be insulated. On the side of the unit here, you have a nice threaded filler and viewing point for the glycol reservoir. So as I was talking, you could hear that the chiller just turned on, and the fan is actually cycling. Our shop is actually cold here in the Northeast right now in October. The fan is cycling on and off based on its fan switching, low ambient control. So we're going to let this thing chill down to 25 or so, and we'll start video number 2 shortly.